Welcome to the course Business Analytics and Data Mining Modeling using R part 2. So, this is the very first lecture, and this particular course is subsequent to an earlier course on Business Analytics and Data Mining Modeling using R. This is part 2 of the previous course. So, it is highly recommended that you go through the previous course video lectures, and there you can get you can familiarize yourself with the basic concepts that are required for this course. You will also get the supplementary lectures on R and basic statistics. So, it is highly recommended that you go through the previous course, that is called Business Analytics and Data Mining Modeling using R. This particular course is part 2 of the previous course, and we are right now in the very first lecture of this. So, two particular modules that we want to cover in this part. The first one is unsupervised learning methods, and the second one is time series forecasting. So, in the previous course we were able to cover the basic data mining part and then supervised learning methods. So, now we will move to unsupervised learning methods in this particular part of the course. So, let us move forward. So, in unsupervised learning methods, the first module that we have will discuss these two techniques. First one is association rules. The second analysis is cluster analysis. So, these are the two techniques, unsupervised learning methods, that we are going to discuss and do modeling using different data sets and the software that we use R. And the second module is about time series forecasting. So, there we have divided it into three parts. So, first one is understanding time series. So, where we will try and understand different components of time series. The second one is where we focus on regression based forecasting methods, and the third one is where we focus on smoothing methods. So, with this let us move forward to our first technique, that is association rules. So, let us discuss first unsupervised techniques that we want to cover, that is the association rules. So, association rules, this particular technique is also called affinity analysis. It is also called market basket analysis, and mainly due to its origin from the studies that happened on customer purchase transaction databases. So, that actually this particular technique is quite popular in the marketing domain, and it is called market basket analysis there. So, let us understand the main idea behind this particular technique, association rules. So, what we try to achieve in this technique is, in this method is, we try to identify item associations in transaction type databases, and then we formulate probabilistic association rules for the same. So, the main idea is from the we look at the transactions and we try to find out what goes with what. So, different groupings between items, association dependencies between items, and from that we try to formulate certain association rules and try to understand which particular items are purchased together or happen to occur in the transactions together. So, market basket databases, they typically consist of a large number of transaction data records. So, any retail store or supermarket where you see the barcode scanners. So, the different items that a particular customer purchases, those are actually recorded, and a transaction is created. So, all those items they in a particular transaction, they become a single transaction, and when there are number of transactions, because of the proliferation of these technologies, there are number of millions of records transactions that are available. So, the idea is to analyze these records and to identify association or dependencies between these items. So, as you can see, market basket databases are about large number of transaction records, and each record consists of all the items purchased by a customer in a single transaction. So, in a single transaction the number of items that are purchased, so that becomes a one record, one transaction, and similar transaction from other customers. So, those large number of transactions then can be analyzed using this particular technique, association rules, and we can formulate some of these rules which can later on be used for, as you can see in the second point, for store layouts, cross selling, promotions, catalog design, and customer segmentation. So, as you can see, the second point, as we talk about, if we can find item groups which are consistently purchased together, this information can be used for these purposes. For example, store layouts, as we talked about, we can design the store layouts in an optimal fashion, because we will happen to know that which items are being purchased together, and therefore the store layouts can be designed to take advantage of that information. Similarly, cross selling. So, we will also know if two particular items or 3, 4 a particular item group is being purchased together, we can create a number of cross selling opportunities. That is why you would see many times baskets, some items are grouped together when you visit supermarkets and retail stores. So, many items are grouped together. So, this is precisely the idea, the cross selling is the idea. So, sometimes they also attach promotional offer, they also give you some discounts. So, how those items are selected for these kind of discounts or cross selling is actually based on more often than not based on association rules. Similarly, catalog design, right. So, sometimes you would see in the catalog design itself, some items are grouped together, if those two items are purchased, then certain discount or something promotion is done, or the catalog, the way items are put together, that itself is based on information that we get from association rules. So, catalog designing and the customer segmentation. So, these associations between items they also in a way tell us the buying pattern of customers. So, using these buying patterns also we can do our customer segmentation. So, you can see a number of areas, a number of issues where association rules can really be useful and used. So, we talk about the association rules. So, typically they are expressed using if then statements. So, these if then statements are computed from data. So, just like in the previous course we talked about classification and decision classification and regression trees, CART algorithm that we discussed in the previous course. So, there also we had certain decision rules. Similarly, in this case, in this particular technique, association rules, also we have these if then kind of statements. So, these statements, this being the unsupervised learning methods, these statements, these rules are directly computed from the data that we learn through coming lectures. So, another example for association rules is the online recommendation systems or recommender systems that you see in online shopping websites of e-commerce companies like Amazon, Flipkart, and Snapdeal. So, whenever you are looking for a certain item and you are examining that particular item, you are on that page. So, if you scroll down and you would see that a number of other items are also being suggested. So, they say customers who purchased this item also purchased some of these items. So, that conjunction for a particular item and these items, that conjunction is created on those shopping websites. So, that is also based on association rules. So, that is one example how where you can understand how association rules can be used. So, if we look at the association rules, it's typically done through a two-stage process. So, first stage is called rule generation. So, in this particular stage we will also discuss the a priori algorithm, and the second stage is assessment of rule strength. So, in the first stage we try to generate all the possible rule, all the possible combinations, and then we assess the strength. So, the rules with higher strength are probably going to be selected for implementation. So, basically two-stage process, rule generation followed by assessment of rule strength. While we are discussing some concepts related to association rules, we will discuss them through this particular example, mobile phone cover purchase. So, in this particular example, the main idea is that what colors of covers customers are likely to purchase together. So, we all have mobile phones, and sometimes we also go purchase the covers for the same, and then different colors of different covers with different colors are available. So, sometimes customers like to purchase different covers with different colors. So, in this particular example, we are trying to we would try to identify the covers which are typically purchased together. So, in this case we have this database of 10 transactions. So, let us look at this particular data set. This is one example that we are going to use in our discussion. So, as you can see in the example, purchase of mobile phone covers. So, you can see in the RStudio here. So, you can see we have 10 transactions in the list. You can see there, first one is red, white, green, then the second one is white, orange. So, each one is actually one transaction. So, some customer purchased these 3 mobile phone covers colored red, white and green. The second transaction where the white and orange colored covers were purchased. Then the third one is where white and blue, fourth one red, white, orange, then red, blue. So, in this fashion we have this. So, this is an artificial example. So, this particular example that we are going to use for our discussion in this particular technique, for this particular technique. So, 10 databases, as you can see. So, we look at the first process in association rules, that is candidate rules generation. So, in this case we typically examine all possible rules between items in an if then format. So, once that happens, then we select rules which are most likely to capture true association. So, we don't want to we want to avoid random chance occurrences. So, we would like to select items which are having some sort of true dependence, some sort of true associations. So, that being the idea. So, however, first we need to examine all possible rules, and then later on select the most these rules with higher strength. So, let us understand this format, if then format. So, in this format, the if part is also called antecedent and the then part is called consequent. So, if we look at these two parts, antecedent and consequent, so they are essentially disjoint sets of items or item sets. So, for example, if we say that if there is a transaction and which involves the mobile phone covers of these 3 colors, red, white and green. So, if we say that red and white we can put in antecedent item set, and the green will go into the consequent item set. So, as you can see that antecedent and consequent item set, they are disjoint, that means they have no items in common. So, while we are looking for these rules, we have to make sure that antecedent and consequent, the if then format that we use to express these rules. So, antecedent and consequent item set, they should not have any item in common, right. So, as you can see through an example. So, if mobile phone cover purchase example, so you can see if red then white. So, this essentially means if red cover is purchased, a white cover is also purchased. So, here the antecedent item set is having just one item, that is red cover, and the consequent item set is having just one item, that is white cover. So, the antecedent and consequent items, they are disjoint, they have no items in common. Essentially, we are trying to say that if a particular item is being purchased, another item is also being purchased. Another example could be if red and white then green. So, that is again, if we go back to RStudio. So, you can see the first one red, white and red, white, green. So, this particular example can be expressed as if red and white then green. We can also say that if red and green then white. So, however, we have to make sure that these sets are disjoint. However, which later on, as we understood that the strength of these rules are to be assessed. So, we will know which particular rule is having higher strength, and probably those rules are going to be selected later on. So, one example could be if red and white then green. So, in this case, as you can see, the antecedent item set is having 2 items, that is red and white, and the consequent item set is having just 1 item, that is green. So, let us discuss a bit more on the rule generation process. So, if we look at the rule generation process, first we need to identify the number of distinct items in a database. For example, this mobile phone purchase database that we have 10 transactions, but out of all these 10 transactions, how many distinct items are there, right. So, because many items would be common across these transactions. So, we need to identify the number of distinct items. So, let us say if there these items are number of these items, number of distinct items are p is p, then in this particular case, if we go back to our studio and if we try to find out the number of distinct item set, here you can see that there are 6 distinct item set in this case. You can see red, white, green, and then orange, blue, and then yellow. So, last one in the last transaction you can see yellow is also there. So, these are the 6 color that we have. So, though we have 10 transactions, so number of distinct item set number of distinct items are 6. If we think about a database which is having millions of transactions, so you can see it becomes a quite quite a computing quite a higher computing intensive exercise to find out the number of distinct items. So, if we look at once we know that number of distinct items that are there in database, we need to find out all possible combinations. So, if we look at just this example where mobile phone cover purchase example 6 distinct items. So, we need to examine single items, pairs of items, triplets of items, and so on. So, if we understand this process, so all those sets with different number of elements in them, different number of items in them are to be examined. So, that would actually require a higher computation time. So, therefore, we need to find a solution for this, otherwise the computation time would be much higher and we will not be able to apply this particular technique. So, what is typically done is we look for high frequency combinations. So, instead of looking for all possible combination as an alternative solution, we can look for just high frequency combinations. So, these combinations are also called frequent item sets. So, instead of all possible item sets, we can look for these frequent item sets. Now, the next question is going to be how do we define what is a frequent item set. So, how this particular frequent item set is defined depends on the concept of support. So, this concept, the concept of support is used to define what is a frequent item set. So, let us understand what we mean by support. So, as you can see, support of a rule is a number of transactions with both antecedent and consequent item sets. So, we have to see the number of transactions in our databases which are having both antecedent and consequent item set. For example, if we go back to the example that we discussed, if red and white then green. So, as we can see that red and white are the red and white create the part of the antecedent item set, and green is part of the consequent item set. Now, we will have to look at the transactions in the database where the antecedent item, that is antecedent item set, that is red and white, is present, and also the consequent item set, that is having just one item green, should also be present. So, both antecedent item set consisting of red and white and the consequent item set consisting of just green, both should be present. So, this particular number will give us the idea of support of that particular rule. So, if this becomes the rule, if red and white then green, then the support of a rule in a sense number of transactions that are a number of transactions with both antecedent and consequent item sets. So, that will actually give us an indication about the support that a particular rule enjoys. So, another way to measure the support of a rule is the degree of support that data provides for the validity of the rule. So, this support of a rule also measures the degree of support the data provides for the validity of the rule. So, let us say if in our mobile phone mobile phone cover example, there are 10 transactions, and out of those 10 transactions 4 transactions are such where both the antecedent and consequent item sets are present, then the support of that particular rule is going to be determined by that number. So, typically a support of a rule is expressed as a percentage of total records. So, if we have an example, for example, previous example that we discussed, if red and white then green. So, in that case if there are 4 transactions in the database where both the antecedent and consequent item sets are present, then out of those there are 4 transactions out of total 10 transactions, and the support of this particular rule can be expressed in percentage term, and it is going to be the 40%, because the 4 is 40% of the total number of transactions, that is 10. So, that would indicate the support that this particular rule enjoys. So, as we can see here, the example item set red and white. So, so this is 40%. If we go back to our RStudio and look at the database, so you can see let us find out how many transactions are there where this particular red and white both are present. So, we can see the first transaction red, white, green. So, red and white are present. The second one not present, just the white. Third one just the white, and the fourth one again red, white, orange. So, here also we can see red and white. The fifth one red and blue, so just the blue. So, sixth one white and blue again not present. Sixth one, seventh one the white and orange, then we have red, white, blue, green. So, here also we can see red and white are present. So, this is the third transaction where red and white both are present. Then the ninth transaction we can see red, white, and blue. So, this is the fourth transaction where red and white both are present. Then the last transaction is yellow. So, out of these 10 transactions we can find out, we can easily spot 4 transactions where both red and white are present. So, this gives us the idea about the support of this particular rule. So, if the item set is red and white, then the support of a rule that so the rule is that we talked about, if red colored cover is purchased, then white is purchased as well. So, support for this particular rule is 40%, as we saw in the data set. So, now once we have computed the support of a rule, how do we again we go back to our previous question, how do we define a frequent item set? So, once we are able to compute the support for a particular rule, so a frequent item set can be defined as an item set having a higher support than user specified minimum support. So, user has to specify what is going to be the minimum support level for a particular item set to be considered as a frequent item set. So, if the support for a particular rule particular item set is higher than that, then that is going to be considered as frequent item set, and these frequent item sets are then going to be used in the rule generation process. So, if we go back to our RStudio, the example. So, if we look at the transactions here, so we have total 10 transactions, and let us say the rule that we considered earlier, the red and white, the item set that we considered earlier, red and white. So there, if the minimum user specified support is 3, then this particular item set is going to be considered as frequent item set. However, if the user specified support is 5, then of course the support for this is 4 or the 40%. So that comes below that user specified minimum support. So then in that case this particular rule won't be considered as a high frequent item set. So in this fashion we can also find out about the other rule. For example, the other example that we discussed, red, white and green. So if red and white if they become the part of the antecedent item set, and green becomes the part of the consequent item set, and if we look at the transactions here, so we find just 2 transactions where all these 3 items are present. So first transaction red, white and green, and then we can see 8th transaction where red, white, blue, green. So there are 2 transactions. So if the minimum support level is 3, then of course this particular item set is going to come below that. So therefore it is not going to be considered as frequent item set. So once we are able to identify the frequent item set given the user specified minimum support level, our next step takes us to the discussion of a priori algorithm, which is the key part of the rule generation process. So we will stop here, and in the next session we will discuss the a priori algorithm and the rule generation process. Thank you.